Okay. We're going to read a couple more graphs. Let me just erase here. And then we'll probably do transformations and be done. Time flies, I'm telling you. 45 minutes? Whew, that's so fast because it's already 5:16. Okay, can you see my screen? Oh,
I'm sorry, what was that?
can you see? Oh, I cut out. I'm sorry. Can you see my screen okay?
Oh, yeah.
Okay. Okay. We want to find 3 times f of 2 plus h of 7. Can you find that value for me and tell me what you get?
Okay. Is the first one 17?
17 is correct. Excellent job. Okay, let's do the second one together. This is also a new notation for you. So, see how it has a couple sets of parentheses? It has f and then it has h of 6. So, whenever you have multiple sets of parentheses, you always want to work inside out. So, first for me, find h of 6. What is h of 6?
3,
Okay. And then once you've got h of 6 is 3, you're going to find f of 3. And what is f of 3?
4.
4. So f of h of 6 is actually just 4.
Okay.
Okay. Okay. Letter C is a little bit more convoluted. We're going to first find f of 4. What is f of 4?
3.
3. Okay, so then once we have 3, the second thing we're going to do is find h inverse of 3. So remember when you see that inverse notation, you look at y and find the associated x. What's h inverse of 3?
Uh, like 0.5.
Okay, so remember when when y is
Oh,
3, what is the, so here, what is the x value?
sorry, I was looking at the F.
You're
What
fine.
for?
You're fine.
Um, uh,
So I kind of made it dark. What x value does it hit?
6.
6. Perfect. Okay. And then for the last part to that, what are we going to do with this outside -2?
Multiply.
Perfect. So what's your final answer?
-12.
-12 is correct. You got it. Okay. How did you feel with that evaluating functions from a graph? Do you feel okay with that?
Yeah.
Okay. Excellent. All right, let's look at a quick application piece to functions. So this is just kind of my, let's throw in a little real world aspect to it, um, just so you understand like how you can see them in the real world. Okay, what's
Okay.
that? 6:30. Mm-hmm. Okay, so this says swine flu is attacking Porkopolis. The function below determines how many people have swine flu, where T is the time in days and S is the number of people in thousands. So they give us the function S of T equals 9T minus 4. Can you tell me the value for S of 4?
Is it 32?
S of 4 is 32. Perfect. And what does that mean in the context of the problem?
Uh, 32,000 people.
Have
Swine flu.
after,
Uh,
think
4 days.
about, yes, you got it. 32,000 people have been infected with the swine flu after 4 days. Perfect. Okay, letter C. Find T when S of t equals 23. Okay, so this time you're plugging 23 in for S of t. What's your t value when you do that?
23.
Okay, so that's not your t value. See how it says S of t equals 23? So that means you're going to plug 23 in here. And what are you solving for?
S? Or,
So see what you're solving for here?
23. Solving for 23.
So yep, so you're going to go 23 equals 9t minus 4. Solve for t. What do you get?
Um, like 2.1.
Add 4, so 23 plus 4 is 27 equals 9t. T equals
3.
3. And what does that mean in the context of the problem?
Um, 3 days.
3 days, or after 3 days, what?
23 people have this line.
23,000. Yes. Okay. Perfect. Got it. Okay, just a little real world application piece there. Okay, the last thing that we're going to look at are transformations of a function: horizontal, vertical shifts, vertical stretches and compressions, and then x axis reflections. When was the last time you were in math?
Like as soon as school ended, which was like a week ago.
Oh, okay. So you took honors math to, or you took math to this last semester.
Yes.
Is that correct? Okay. And did you only take it from January to May?
Yeah.
Okay. And then next year, your class math 3 is only a semester. Is that correct?
I think so. Yeah.
Okay. Okay. That is funny how Providence is doing that, and yet my school is doing a year-long class for it, which is strange. But could you imagine being in a math class year long? I mean, like high school math class year long. Isn't that crazy? And then to have to take an EOC in the class, which is from August to May. Isn't that crazy?
Yeah.
Oh, it's gonna be long. Okay, so you then are probably well versed with those transformations: shifts left, shifts right, shifts up, shifts down, and then x-axis reflections, if applicable, vertical stretches or vertical compressions. Let's look at number 1 here. What does that leading negative mean has happened to the graph?
It's gonna be like upside down.
Yes, x-axis reflection. Okay, what about that leading 3?
It's stretched or compressed by 3, I think.
You're correct. It's actually stretched. So does it make it wider or narrower?
Narrower.
Narrower. Perfect. Vertical stretch by a factor of 3. And what about that plus 1 at the end?
It moves it up 1.
Up 1. Vertical shift up 1. Excellent. Okay. Number 2, parent function is your absolute value. What are your shifts here for number 2?
We didn't really do the absolute value, so I'm not really sure about that.
Okay, so anytime you have something added to x, so it could be inside the absolute value, it could be inside parentheses, it could be under the square root, it could be up in the power of the exponent. Anytime you add, it's a shift left. Anytime you subtract, it's a shift right. So this would move left 4, and where's it going vertically?
Down 1.
Down 1. Perfect. And I just want to show you real quick on Desmos, which is definitely a tool you're going to be using a lot this year. here. So if you ever get, can you see my screen?
Yeah.
Desmos. Okay, so if you ever get confused and you want to check yourself, you go +4. See how it goes to the left? Okay, and then if I did -4, see how it goes to the right?
Yeah.
And then if I did it on the outside, did +4, where does it move?
Vertically.
Vertically up. Perfect. And let's say I did, I'm just going to go to the right 2. I'm going to go -2. But if in the front I put a 2, what happens to the graph?
It's getting narrower.
Yep, it stretches vertically. It's a vertical stretch. But what about if I put 1/2? What happens to the graph?
It gets compressed.
Yep, it's a vertical compression. Excellent, excellent. It gets wider. Good work. Okay, just wanted to make sure you saw that. Okay, and let's do this last one here. So again, even though you may have not done absolute value, those transformation rules still kind of all apply. What does that outside 2/5 do?
It compresses it.
Yep,
By 2/5.
vertical compression. Good.
Yeah.
Okay, and then what about on the inside? What does the -2 do?
It moves right.
Right 2. And then what about the outside?
It goes up 3.
Up 3. Beautiful. All right. You did wonderful. How did you feel with everything?
I think it was pretty good.
Pretty good. Do you feel like it was kind of like a good lesson?